This video is going to cover the law of cosines and the law of sines. The neat thing about law of cosines and law of sines is you can use it on non-right triangles to solve for a missing angle or a missing side. Okay, first one we're going to look at is the law of cosines. Okay, we've got this formula here, c squared equals a squared plus b squared minus 2ab times cosine of c. Okay, if you notice, we've got three sides, lowercase letters, of our triangle here, and one angle. Okay, so that means we can use this for two different situations. Okay, if we have three of the sides, we can find the missing angle. Or if we have two of the sides and the included angle, we can solve for the third. Okay, so side, angle, side situation. Okay, to help remember the formula here, you don't really have to concentrate on A, B, or C. Okay, you've just got one side all by itself and one angle way on the end here. Okay, if you notice, the angle that we use is opposite the side that goes by itself. Okay, opposite in the formula and opposite in our picture here. Okay, then we'll have the sum of the other two sides squared minus 2 times those other two sides multiplied by the cosine of our lone angle. Okay, so let's use that to talk about the first problem here. We're looking at the distance of a laser telescope to the center of a throwing circle. Okay, so on our picture here, laser to throwing circle is 30.10 meters. Then from the same telescope to the target is 51.02 meters. Says the angle between the telescope's path to the target, so that line I just drew, and the target, and the telescope, to the center is 95 degrees. We want to know what's the length of the throw from our center of our circle. Okay, that's marked as C in our picture here. Now, we want to focus on the angle and the side that's opposite for law of cosines. So in this case, it's 95 and C. This side will go all by itself in our equation. Now, it just so happens that it's C in this and C in the formula that we used. Okay, but don't worry about that. Just whatever's across from the angle we're given, that's going to go by itself. Okay, so we've got C squared, then our other two sides squared in whatever order you want, 30.10 squared plus 51.02 squared, and then minus 2 times A times C. Okay, it's just going to be your other two sides. I usually go in the same order that I listed them, but it wouldn't really matter. Times the cosine of our angle, which was 95 degrees. Well, if I'm trying to solve for C over here, you'll notice all this other junk is on the other side. Okay, that makes our life easy because we can just type the whole right-hand side into our calculator. We've got 30.1 squared plus 51.02 squared minus 2 times 30.1 times, I'm putting multiplication instead of parentheses, but it means the same thing, 51.02, and then cosine of 95. Okay, this 95 is in degrees, so make sure that your mode is actually in degrees while doing this. Okay, if your number matches up, then your mode is good to go. But that's not the length of a discus throw, because we've got c squared equals this number. So c squared was approximately that 3,776.74, and I'm going to take the square root to actually find the length of my throw. Okay, so we've got to take the square root of that answer. Okay, if you remember, we can grab that number by just taking second and then our negative. We'll take the last thing in our calculator's brain here. So we've got approximately 61.46. I'm just rounding to what they rounded to here because they didn't tell us. Okay, and that is in meters. Now, anytime you get done with one of these problems, you want to ask yourself if that's reasonable for what we're talking about. Okay, if you notice here, we've got 95 degrees, and that's the largest angle, so we've got our longest side across from it. It is the largest number, so that's awesome. Okay, but also we're talking about the throw of a discus. Okay, so 61 meters is pretty reasonable. We don't usually measure in meters, we measure in feet. Okay, but 61 is a reasonable number for the throw of a discus. So always ask yourself that question, does my answer make sense to the problem? Okay, that'll help make sure you set it up right, especially when you have to go draw these pictures by yourself. Okay, next example, we are given 3 different sides. So this is a side, side, side situation, and we want to find the measure of the largest angle. Well, the largest angle is across from the largest side, so it's asking us here to solve for C. Okay, that pair is important because that means our 8 side has to go by itself. Then we'll have our other 2 sides, 6 squared plus 5.3 squared, minus 2 times our other sides, so 6 and 5.3 again. Then cosine of our angle, which in this case is C. This time we're solving for an angle. Okay, we've got things happening on both sides of our equation, so there is a little bit more work here. If you've noticed, we've got 2 times cosine, but then it's cosine of C. So before I can take the inverse, I need to get cosine by itself. And before I can do that, I need to move this other junk out of the way. Okay, so my first step is to get rid of that addition and move it to the other side. Okay, to move it to the other side, we'll subtract. Okay, so you don't have to write this, but this is what I'm going to do in my calculator, and this will save you some time here. To move it, we're subtracting. So in my calculator, I'm just going to go get 8 squared minus 6 squared minus 5.3 squared. We want to find out what that number is. Okay, so 8 squared minus 6 squared minus 5.3 squared. And then we'll just jot that number down, negative 9/100. Okay, we move that over, so now I've got all this still left, and I can simplify the numbers in front of cosine. Okay, we've got negative 2 times 6 times 5.3, and I'll jot that number down as well. Okay, so negative 63.6 times the cosine of C. Okay, you notice I said times, even though I don't have it written here. That means to get rid of it, I've got to divide that 63 away. Again, you wouldn't necessarily have to write down this step. Kind of just helps you remember what we're doing for these problems. We've got negative 0.09 divided by, I've already got that in my calculator, so I'm just going to use the answer function again. So the cosine of C is approximately, I'll jot down a few decimals here, just so we know what to do next. And in order to get that C out of cosine, I have to take the inverse of this number. So I'm taking the inverse cosine of that answer to get C is approximately 89.9 degrees. Okay, I'm just going to round to 1 decimal here because it doesn't really tell me, and I've got 1 decimal up there. Okay, if it doesn't ask, I'm not super picky, you can round to 1 decimal each time. Alright, our next problem, we've got a parallelogram, has a 70-degree angle, and side lengths of 10 inches and 15 inches. We want to know what the length of its longer diagonal is. Okay? We struggle the most sometimes with drawing pictures, so what I'd like you to do is pause the video and see if you can set up this problem. Just draw me a picture. Okay, so I'm sketching this parallelogram, and I'm told I have a 70-degree angle. Well, in a parallelogram, opposite angles are congruent. Notice I put it for the acute angle here. I've also got other angles right now, but we'll come back to talking about those. Side lengths, 10 and 15. Opposite angles are congruent, but so are opposite sides. so 10 and 10 and 15 and 15, I want to know the length of the longer diagonal. In a parallelogram, the longer diagonal will be the diagonal that connects the acute angles every single time. Okay, they won't be the same length. You can't always rely on your picture, especially if your sketch looks as bad as mine. Okay, it will always, always be the one that connects the acute angles. Okay, so we want to know the length of that. I'm calling it x. Well, in order to use law of cosines to solve for a missing side, I need to have the sides on the outside of my angle. Well, the sides that I'm given in my triangle, and I'll highlight it here so we can see it, are 10 and 15, but I don't have the included angle. So that means I need to know that, or I need to be able to figure it out from my picture. Well, not only are opposite angles congruent in a parallelogram, but adjacent angles are supplementary. So if you take 180 minus 70, you'll get that missing angle of 110. Now we have enough information. Go ahead and set up your problem and solve for your missing side. X has to go by itself here, and then I've got 10 squared plus 15 squared minus 2 times 10 times 15, then the cosine of that angle 110. Since everything is on one side, type the whole thing in. Should get x squared is approximately 427.6. Again, keep that number in your calculator so you don't have to round. And x is approximately 20.7. We're labeled in inches here. Okay, always double check, make sure that's reasonable. Okay, in our picture here, we've got the longest side. It has to be bigger than 15, and it definitely is. Okay, the next problem, to the nearest degree, find the measure of the smallest angle in a triangle with side lengths 4, 5, and 6. Okay, go ahead and draw yourself a picture here and see if you can find the missing angle. Okay, remember this one is a little bit tougher, but I want to see if you can remember the process. Now, I'm going to call my triangle ABC, but you don't really need that for your information. We just need side lengths of 4, 5, and 6 centimeters. And then we want to know the smallest angle. So, smallest angle in my picture is A. You could have called it whatever letter you wanted to. Okay, that means 4 has to go by itself. Other sides in whatever order you want. Just filling in for our unknown here. Hopefully we're getting closer to having this formula memorized. Okay, I'm just going to show you the calculator work for here, because what I would do is take 4 squared minus 5 squared minus 6 squared, enter, and write that number down, negative 45. Then I would take negative 2 times 5 times 6. Now that's easy math, but I'm going to go ahead and type it in anyway. Negative 2 times 5 times 6, because usually they're a lot uglier. And then I know that I have to divide this 60 over. So I'm going to take negative 45, the first number that I jotted down, and divide it by the last thing that was in my calculator. So I've got 0.75 equals cosine of A. And really, you don't need this step if you know what to do next, which is take the inverse. And you get your angle to the nearest degree is approximately 41 degrees. The next problem, we've got the law of sines. Okay, you'll see why it's law of sines because of the picture here. We've got a campground, and they want to know the distance F across the lake. They measure the distance from the flagpole to the headquarters and measure the angles indicated, and they've labeled them for you here in the picture. Our job is to find the length F. In order to do that, we need to know the angle across from it and the sides on either side. Okay, if you notice here, we don't have that information. Okay, so we're not allowed to use the law of cosines here. That's where the law of sines comes into play. Okay, so I'm going to talk about law of sines a little bit and then come back to talking about this problem. The law of sines works for non-right triangles as well, and we've got this proportion set up where the sine of the angle over the opposite side is going to be equal to the sine of the other angle over opposite side and third angle over the opposite side. Okay, but we want a formula or an equation, and that means only using one equal sign. We can pick on any two pairs here. Okay, remember, just like with the law of sines, the letters themselves don't really mean anything. Okay, you just need to focus on, we need two pairs of angles and two pairs of sides. Okay, so we're allowed to use the law of sines to solve for a missing angle or a missing side. This is going to be useful since we've got two angles and two sides in an angle-side-angle situation where we would find a missing side, an angle-angle-side situation to find a side again, or we can use it to find a missing angle for side-side angle. Now, this last case is going to be a little bit tricky because when you're finding a missing angle, it's not going to be unique. Okay, so that's what this part down here says with your asterisk. If solving for an angle, there might be two angles that satisfy your equation. We have to check both the angle that our calculator gives us, that'll give us one answer, and the supplement of the angle. Okay, and that's because we're dealing with sine. And if you remember, sine of an angle and sine of its supplement are congruent. Okay, they're the exact same sign, so that means there's actually two different angles that would satisfy the equation. Okay, that's going to be important because when we're dealing with our triangles here, we want to make sure we get all possible options. Okay, so let's go back to the camp problem and deal with finding this missing side F. Now, on your equation here, we've got in the proportion angles on top and sides on bottom. I'm going to tell you that it might be better to flip this around and have sides on top and angles on bottom. The way to know which one to do is by where your unknown is. Okay, so our unknown here is a side. We'll want to put the side on top. Always, if you can, put your unknown on top, and that will save you some extra work when solving. Okay, so F is across from 40, so sine of 40 will go on the bottom. And then we need to pick on our other pair. If you notice, we were only given one other side length. You have to use that. So our other pair will be 400 on top, but I need sine of the angle across from it, and right now I don't have that. Okay, but we know the angles in a triangle have to add up to 180. Right now I've taken care of 150 of it, so there's 30 left over, so sine of 30 on the bottom of that 400. Now, most people, when they see proportions, they want to solve it using cross multiplication, and you are welcome to do that if you'd like. However, since we put our variable on top, we can actually solve this in one step by just multiplying by the sine of 40. Okay, that gets the variable all by itself and saves us a little bit of work. Now on this side, I kind of put it on the top because that's going to save us a button to press in our calculator. Okay, but you're welcome to do this part first and then multiply it by sine of 40 as well. So now that F is by itself, we'll just go type that in. 400 sine of 40 divided by sine of 30. Make sure you get your parenthesis on there or you'll have some weird things happen. And it tells us that that distance is about 514.2 meters. which is reasonable because 400 is across from the 30, so we know it has to be larger than that. Okay, so it kind of makes sense in terms of our problem here. Okay, we're going to come back to talking about this area, but I want to focus here on part A. We've got another triangle, ABC, and we're told the measure of angle A is 32 degrees. I'm just going to start sketching this. And then AB is 8, and BC is 5. We want to find all the possible values of this measure of this angle. Okay, so this is the tricky part where there might be more than one answer. That's why it says all possible values, because when you solve for an angle, there might be more than one. Okay, so let's set this up. We need to use C, and since C is our unknown and it's an angle, I'm going to put angles on top. Then our other pair that we can use is 32 and 5, so sine of the angle on top and 5 on the bottom. To get C by itself, I need to move over the 8, and I will put it in front because that makes life easy. And then to get C by itself, you just have to take the inverse. Now, you can get this number as a decimal here first, or you can type in this whole junk here. It might be easier, so you don't have to worry about a ton of parentheses, to just take 8 sine of 32 divided by 5, and we need to take the inverse of that decimal, that 0.8479. To the nearest degree, that's about 58. And that works in our triangle here. Okay, but we also, for law of sines, when we're solving for an angle, have to check out the supplement. So we'll take 180 minus that 58. Since the 58 was approximate, so is the other one. And we'll get 122 degrees. Now, the reason it says might have two possible answers is because we have to check and make sure this number works out if I put it in my triangle. Okay, if I have 122 here, and one of my angles is 32, I just have to make sure I still have room for another angle. Okay, if I take 132 plus 122, I'm at 154. There's still room left in the 180 degrees to get to my third angle for my triangle. Okay, so there is another triangle that exists, and it says sketch it. So A, B, C here. Okay, if you notice, I tried to get an obtuse angle there instead. So now what we're going to do is go ahead and find the other angles. Okay, it's easy to do for us, and it's going to help us find the area using these formulas up here. Okay, so we've got 32 plus 58 is 90. That means there's 90 left over. 32 plus 122 is that 154. There's 26 left over. So those are our possible triangles. On your homework, you'll be asked to solve the triangle. If it asks you for that, you would need to do one more step here and go find this missing side here. Okay, but finding the side using law of sines is pretty straightforward here. So I'm going to move on to talk about the area of the triangles. In our formulas back up here, we've got the side, angle, side, area of a triangle. So if we know two sides and the included angle, we can find the formula by taking 1/2 of those two sides multiplied together times the sine of the included angle. Okay, so let's do that for both of our triangles here. There's two different ones, so we're going to have two different areas. and we'll have 1/2 the two sides that we're given, 8 and 5, times the sine of the angle in between. So the angle in between here is the 90. Okay, you're welcome to type that whole thing in normally. Hopefully we know by now that sine of 90 is 1. So this is really just 1/2 of 8, 4 times 5, or 20 units squared. Now I'm going to put an approximation here because even though this number came out nice to 20, this 90 up here we got by rounding, so it was actually approximate area as well here. Our second triangle, still 1/2 8 times 5, but this time my included angle up here is the 26 degrees, so it's sine of 26. Okay, this whole part was 20, so 20 sine of 26 is about 8.8 units squared. Okay, example 3 is very similar to example 2. What I'd like you to do is pause the video and see if you can go find the measure of angle Z. Okay, I've got my drawing here. I'm told X is 42.5, and then little x is 10, little z is 3, and I need to find z. Okay, we can use law of sines. We've got opposite here, sine z over 3, and then other pair is sine of 42.5 over 10. Again, I put my variable on top, that way I can solve pretty easily. So I just need to take the inverse. Now this is going to look a little ugly here, but I'm just showing you can actually do it all in one step. I know I need to take the inverse of all of this mess here. Okay, so I can say the sine inverse of 3 sine 42.5, make sure you close it there, divide by 10 and close it again. Okay, this is why if you don't want to worry about a bunch of parentheses, just go grab that number and then take the inverse using the answer function. So z is about 11 to the nearest 10th 0.7 degrees. Okay, but we also want to check the supplement. So 180 minus that 11.7 degrees. So 168.3. Now, if I look back in my triangle here, 168 and the one I was given, I go over 180 degrees. That means this angle cannot exist in this triangle. So this is one of the situations where the supplement does not work. Okay, you just have to check it. Okay, so the supplement does not work here. The area, we're going to take 1/2 the sides we were given, and then sine of the angle in between. Okay, my angle down here was 11.7, so I just have to go find the angle that's in between. Okay, that should be 125.8. So I've got 15 sine of 125.8. So my area is about 12.2 units squared. So on your homework, what it's going to look like is a bunch of word problems. Okay, they all have to deal with triangles, but you have to decide which method is best to use. Okay, so in general, these are the steps you're going to go through. First, you want to see, is it a right triangle? Because if so, your life is going to be a lot easier because you can use SOHCAHTOA. Okay, SOHCAHTOA is very easy to solve for sides or angles. If not, then you have to decide whether it's going to be law of sines. Okay, that's the angle, side, angle, 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 side, or side, side, angle. Okay, remember that this last one, okay, might have two answers for your angles there. Or law of cosines if you're given three sides or two sides and their included angle. Okay, if you have any questions on this video, be sure you come in and ask.